In this video, I'll go through a quick example of finding the equivalent resistance, using a combination of parallel and series resistances. So let's assume we have a circuit that looks something like the one that I'm showing here to the right. So we have R1 is equal to R2 is 100 ohms, R3 is equal to R4, 150 ohms, R5 and R6 and R7 are equal to 200 ohms, and finally R8 is equal to 300 ohms. So what is the equivalent resistance? So first, I'm going to start from the right. So notice that R7 and R8 are in parallel. So I'm going to call their equivalent resistance R equivalent 1. So it's R7 in parallel with R8. So I go here, R7 is 200 and R8 is 300 ohms. So 200 is in parallel with 300 ohms. So if you use, basically two resistors in parallel, it's just their product divided by their sum. So that's what I'm doing here. So I get 120 ohms. So this is R equivalent 1. So once I get this R equivalent 1, I notice that it's in series with R6. So now I'm going to get that equivalent resistance, which I'm calling R equivalent 2. So it's R equivalent 1 plus R6. So if I do the math, it's 320 ohms. So basically up to here, so I got the equivalent resistance, which is R equivalent 2. So once I get that, I notice that R equivalent 2 is in parallel with R5, and it's also in parallel with R4 and R3, because if you notice, they all share the same kind of node, or they have 2 points of connections. So I'm going to call it R equivalent 3. So it's R equivalent 2 in parallel with R5. So for now, I'm just going to do R5, and I will address R3 and R4 next. So R equivalent 2 is 320, R5 is 200. So if I do the math, it's 123.08 ohms. So now R equivalent 4 is equal to R equivalent 3, which is in parallel with R3 and R4 and R2. So when you have resistors in parallel, their equivalent is 1 over the sum of the inverse of all resistors. So it's 1 over 1 divided by R equivalent 3 plus 1 over R3 plus 1 over R4 plus 1 over R2. So if you do the math, it's 31.79 ohms. So basically, I got the equivalent resistance from here, looking back towards what I started from. So all this is R equivalent 4. So now R equivalent 4 is in series with R1. So the equivalent resistance of this circuit is R equivalent 4 plus R1. So R equivalent 4 is 31.79 ohms plus R1, which is 100 ohms. So it's 131.79 ohms. So kind of the technique or the strategy followed in solving this problem, basically, I started from the right, and I was kind of like recognizing, like in this example, R7 is in parallel with R8. So I found their equivalent. Then I noticed it was in series with R6. So I found the equivalent. I noticed it was in parallel with R5. I found the equivalent. Then I noticed it was in parallel with R3, R4, and R2. I found the equivalent. So you do it one at a time, And for instance, R7 and R8, if you look at this point here, this point and this point are the same potential. So basically, this is just one connection because there's no resistance here, and you do the same thing here. So that's how I figured they were in parallel. The other thing, obviously, if current flows through R6, some of it is going to go through R7, some of it is going to go through R8. That means they are in parallel. So those are just ways, to handle series and parallel combinations, which can be confusing. Thank you, and hope this video will be helpful. Have a great day.